Hello lads and lasses, welcome to Malpha Theta's SAT tutorials. In this video, I'll be going over Domain 3, which is problem solving and data analysis. You can type in a link at the top of the screen for the slides, but I'll also leave it in the description. Real quick, there are also QR codes to different resources you can use. Of course, the questions and answer key are on the left. There's also a link to the College Board Desmos, which is the specific version you can use on the SAT. And I have this pulled up on the right here. And there's also some notes that I typed up. Let's go ahead and get started. These are the topics that we'll be going over. If you were in person, this is how the slides would work. I would go through certain questions, and any marked with a cow would be ones you can try out yourself. Since this is online, I'll obviously be going through every single question. Feel free to follow along or try some out on your own. There's also this form that you would fill out, but once again, I will be going through all of them anyways, so you don't need to fill this out. Here we go with our first topic and question. They tell us that the International Space Station has an average speed of 4.76 miles per second. Then they want us to convert that into miles per hour. If we take a quick look at the notes, I do tell you how you need to do everything for dimensional analysis, which is basically just converting units. You can read that on your own time if you want, but I will be explaining it in my own words. Well, I mean, I guess that was my words too, but you know what I'm saying. First up, we want to write the number they give us as a fraction, and there is an easy way to do this. The word per means you're dividing. So here we have 4.76 miles, we would put that as the numerator. And then we have the word per, that would be our division sign. And then second would be on the bottom. So 4.76 miles per second would be the same as 4.76 miles divided by technically 1 second. Now we need to convert this second into hours. And we can do that by multiplying it by equal ratios. So first up, we would probably want to go from seconds to minutes to hours. How many seconds are in 1 minute? The answer is 60 seconds. Whenever you're multiplying, you want to make sure the same unit is across from each other. So here we would want 60 seconds on the top, and then 1 minute on the bottom. That way the 2 seconds would technically cancel out. Once again, we will want to have minutes and hours, so we multiply this by 60 minutes in 1 hour, and then once again the minutes would cancel out. So now we would really just have 4.76 times 60 times 60. The seconds would cancel out, the minutes would cancel out, so now you would be left with miles over hour, which is the same as miles per hour. There you go. Let's go ahead and do that by putting it into Desmos. 4.76 times 60 times 60, and we get our answer would be 1,700, wait, that's 70,000, my bad, 70,136. Miles is still on the top, and then hour is on the bottom. That means our answer will be D. Slide number 7. They want us to convert 76 quarts into fluid ounces. Let's go ahead and write that down, 76 quarts. And now we need to start multiplying by our ratios. Luckily, they actually give us them. We're going to start off with cups and quart, because obviously we have a quart and we need to get rid of that. So once again, you want your quarts or your same units to be across or diagonal from each other. So we would want to have 1 quart on the bottom, and then 4 cups on the top, because technically this would be over 1, and you want your quarts to cancel out. Same thing here when we're going from cups into fluid ounces. We want our cups to be on the bottom so they cancel out. And then our 8 fluid ounces on the top. Now if we went ahead and multiplied this all out, the quarts would cancel out and then the cups would cancel out, leaving you with just fluid ounces, which is what we're solving for. So let's go ahead and multiply this out in Desmos. It would just be 76 times 4 times 8, and we get our answer would be 2,432 fluid ounces. Oh, I missed the box. Slide number 8. They give us an area of 92.1 square miles and say that 11.3 square miles of that is water. Then they tell us it has a population of 621,000 people and want us to find the population density. Here's the important part though. The unit is gonna be people per square mile of land area. Notice it specifically says land area, which means we're not gonna be including this 11.3 miles of water. Alright lads, you might be saying, how do I find population density? I didn't give you an equation for that, and it's not on the notes either. But guys, you don't even need to know it. It tells you, really, in the unit. We know it's gonna be people over square mile of land area. We know this is what we're ultimately gonna end up with. So I think you can tell what number is gonna be on the top and what number is gonna be on the bottom for you to get these units. Obviously, you would have the 621,000 people on top. And then on the bottom, you would have the square miles, the area. But once again, it's only land area. So we have to take our total area of 92.1 and subtract 11.3 miles of water from it. And would you look at that, we have our equation now. You don't need to memorize no equation, just look at the units. Alright, let's go ahead and put this in Desmos to calculate it. 62,1000, I don't know why I said it like that, and then 92.1 minus 11.3. And we get our answer is roughly 7686. So that means our answer would be D. Wait, that's B. The answer would be B. Slide number 9. This time, they give us the population density. They tell us it's 230 people per square mile. Then they also give us the population of 85,100 people. Now they're asking us for the area. Let's go ahead and write down what they give us. The population density. We know it's going to be 230 people per square mile, which also just means divided by square mile. And of course, we know this would also be equal to 85,100 people divided by the area. Because the unit of area would also be square miles. You know what I'm saying? It's just like the last question where we solved for population density. Alright, well, I tried making that smaller, but that didn't really work. Whenever you have two fractions set equal to each other, you can just cross multiply to find out what you're solving for. So we would have x for area. Then we would just cross multiply like that. So we would have 230 people times x area is equal to 85,100 people times 1 square mile. And then to solve for x, you would just divide by 230 on both sides. And let's go ahead and put that in Desmos. We would get that x is equal to 370 square miles. Now we're moving on into our next topic. Let's get started with slide number 11. They tell us that 140 is p% greater than 10 and ask us to find the value of p. Let's go ahead and take a look at our notes. You'll notice that right here under percentages, you always want to use this percent change formula when you're solving for a percent. And here we are solving for a percent because p is a percent. I forgot to change to purple. Alright, and here's the equation we're gonna use. Oops. New minus original over original times 100. And here's the thing. I don't know if this is actually true, but based on my experience, the new number is always going to come before the percent. So if we look before the percent, that means 140 would be our new number, and then 10 would be our original. So let's go ahead and put this into our equation. New minus original over original times 100. 140 minus 10 divided by 10 times 100. And this would get us the value of p. So let's go ahead and put this into Desmos. 140 minus 10 over 10 times 100. And we get our answer would be 1300. So that means our answer will be B. Slide number 12. Once again, exact same question, different numbers. 210 is p% greater than 30. What is the value of p? Now whenever you're solving for a percent, the easiest one is always going to be this percent change formula. But there is another formula you can use, and it's right below it. It's going to be the percent increase / decrease formula. Now this is going to be new is equal to original times 1 plus or minus the percent. Of course, if it's percent greater, which is what it is here, p percent greater, you're gonna be adding the percent. So this would be a plus. And if it's less, you'll be subtracting. So let's go ahead and just plug into this equation. For funsies, you know, it's always fun to know different ways to do it. Our new number would be before the percent, so that's gonna be 210. Our old number is gonna be after, so that's gonna be 30. That's supposed to say OG, not old, whatever. Now this is new equals original, so 210 is equal to 30 times 1 plus the percent. Now remember, whenever you have a percent symbol, that's the same as dividing by 100. You know, because a percent, like 60% would be 60 over 100. So we will just have p over 100. And we can go ahead and just solve for p now. You could just do it by hand. Divide by 30 would get you 7 is equal to 1 plus p over 100. And then subtract 1. 6 is equal to p over 100. Multiply by 100. P is equal to 600. Or you could also put it in Desmos, which is obviously my preferred method, even though I just did that way faster, honestly. Instead of putting a p, you can just put a x. And I forgot, you can't put a number by itself, you have to put y equals. And now we just find a point where these two lines intersect. And would you guess it? It's at x equals 600. Once again, our answer is 600. Slide number 13. Here they tell us that the number w is 110% greater than the number z. Real quick, 110% greater, that means we're going to be using the percent increase formula, so put a plus sign there. And then they tell us the number z is 55% less than 50. So that would be percent decrease because it's less. So we would use a minus sign or a subtraction. And then they ask us to find the value of w. So real quick, let's set up all of our equations with our percent increase and percent decrease with our numbers, or technically I guess our letters. First up, we know that for our percent increase formula, w is going to be the new value because it's always before the percent, and then z would be the original. So let me see it real quick. New is equal to original, so w is equal to z times 1 plus 110%, so that would just be, once again, 110 divided by 100. And then in our second equation, z is 55% less than 50. Z would be our new value because that's now before our percent, and then 50 would be our original. So new is equal to old times 1 minus, because it's percent decrease, our percent, so 55 over 100. And now they want us to find the value of w. And there's two ways we can do this. The first way is that you can just put both equations in, and then you would have a system of equations. The second way is that we can just substitute this entire thing for z. So instead of having z up here, we can just plug that in. And that's what I'm gonna do, because it's less typing. Wait, technically wouldn't it be the same amount? Okay, whatever, I'm just yapping. Alright, so w is equal to z, but instead of putting z, we're gonna put 50 times 1 minus 55 over 100. And then that's gonna be multiplied by 1 plus 110 over 100. And would you look at that, we get that w is equal to 47.25. Slide number 14. Exact same question, just different numbers and letters. Let's write the equations as we go. The number a, so a is 110% greater than the number b. A is our new value, b is our original value, times 1 plus the percent, divided by 100. The number b is 90% less than 47. B is our new value, 47 is our original value, times 1 plus the percent, divided by 100. My bad, I was kinda in the zone, but this is percent less, so this should actually be a minus sign, not a plus. Whoops. Then they want us to find the value of a. Just like before, let's go ahead and take this entire piece and substitute it in for b. Let's put this in Desmos. A is equal to, instead of b, 47 times 1 minus 90 over 100. And then 1 plus 110 over 100. And we get that a is equal to 9.87. Now we're moving on into our next topic, Let's get started with slide number 16. They give us this table and ask us for the maximum data value. Guys, maximum means biggest or largest, and data value is this entire column on the left because it says data value. What's the biggest number in this column? The answer is 14, so that's quite literally our answer. It's 14. Slide number 17. They ask us for the range of the list above. If we go ahead and take a quick look at the notes, you'll see right here, range is the maximum minus the minimum, or basically the biggest number minus the smallest number. Now you can put a list and do all of that, but I'm a little lazy, so let's just look for the biggest number and the smallest number. Alright, 52 is the biggest number and 23 is the smallest. 52 minus 23 is, I'm gonna say it's about 29. Let's see if I'm right. No way I'm right! Oh my goodness, I'm actually the greatest. Alright, 29 is our answer. Slide number 18. They give us 4 lists in our answer choices and ask us in which one is the mean greater than the median. Let's take a quick look at the notes. The mean is gonna be the average, and the median is gonna be the middle number of a list. Now you can see finding the mean and median are gonna be a lot of work. So instead, let's do the Desmos method and make a list inside of Desmos. Alright, this is also gonna be a lot of work because we gotta go through every single answer choice until we get the correct one. First up, when you make a list, you wanna just choose any capital letter. Now I'm gonna choose L for list, and then you're gonna put an equal sign, and you wanna click the bracket key on your keyboard. It's right next to the P, the bracket. And then you wanna type in all of the numbers in your answer choice. So let's start off with A. We're gonna have 1, 2, 3, 4, 5, 6, 7, 8, 9 5s. Alright, and now when you want to find the mean, you're just gonna type up mean, and then in parentheses, you're gonna put the letter of the list you made. So capital L. And we get that the mean is 5. Same thing for median, just type in median, parentheses, and the capital letter of your list. And you'll see that the mean and the median are both 5. So, back to our question, is the mean greater than the median? No, it is not. So A is not going to be our answer. I'm pretty sure y'all can see where this is going. We're going to have to go through every single answer choice. So, I'm going to just speed this part up for you. Alright, I went ahead and typed in answer choice B. I realized I probably should have just put A instead of L equals, but it's whatever. Here's our mean and median, and you'll notice that they're both the same. So B isn't gonna be our answer either. Alright, here's answer choice C, the mean and the median. You will notice that the mean is greater than the median this time, so C will be our answer. But for fun, let me also do D. Alright, here's answer choice D. Here's the mean and the median. And this time the mean is less than the median. But of course that's not what we're trying to find. We want the mean to be greater than, so D wouldn't be our answer either. Once again, our answer is C. Slide number 19. They give us a table and want us to find the mean, median, and mode, and sort it from least to greatest. Same thing here, since we're trying to find the mean and the median, I'm gonna just go ahead and put it in Desmos. Choose any capital letter, L for list, equal sign, and then a bracket. And now we want to type in our data values. For 18, you'll notice that the frequency is 6, so that just means type 18 6 times. And you also notice you have a counter in the bottom right, the number of elements. That's gonna help you keep track of how many you have. Eventually at the end, since this is a list of 20 students, we want to make sure we have 20 elements, or a 20 element list. Let me go ahead and type in the rest of these numbers. Alright, I went ahead and typed in all of our data points. We have a 20 element list which matches with the 20 students, so that's good. Now we want to find the mean and median, so mean, parentheses, the letter you used, so capital L, and then median, parentheses, capital L, and this is the value we get. So we found the mean and we also found the median. Now we need to find our last bit, which is the mode. Let's take a look at our notes. The mode is the most frequent number, and unfortunately you cannot use Desmos. If you type in mode, nothing will happen. Now this is going to be really easy. Usually you would have to just count, but in this question, it gives you the frequency. What's the most frequent number? Well, maybe the one that has the greatest frequency. And of course, the answer would be 18 because it has a frequency of 6. Let me quickly write all that down. So this is the value of the 3 different stats we got. The mode is 18 because it has the biggest frequency. The median is 19 because Desmos said so. And the mean is 20 because Desmos also said so. Now if we go from least to greatest, that means our answer will be A. Now we're moving on into our next topic. Let's get started with slide number 21. Here they give us a scatter plot and ask us for an equation that gives the line of best fit. The line of best fit is basically just going to be a line that goes through most of the points, so something like that. Now you could calculate the line itself by doing linear regression, and I do go ahead and explain so in the notes. Oops, I don't know what I just did. But that takes a lot of work, and I don't want to do that. So instead, we're going to plug in all of our answer choices and see which one would match. First up, you notice that the x-axis goes from 0 to 6. So let's go ahead and adjust our graph in Desmos to do that. You want to click this icon up here in the top right where it says graph settings. And then under x-axis, we're going to go from 0 to 6. And then from y, it goes from 0 to 20. Same thing, y-axis 0 to 20. Now let's start plugging in all of our answer choices. First up, this is in y equals mx plus b form, slope-intercept form, where b is your slope-intercept. We know for sure that b is going to be a positive slope-intercept, so we can't have a minus, and we can't have a minus. It's either going to be A or C. Here's A, and if we compare the two lines, the one that I drew is definitely a lot steeper than the one on Desmos, so it's probably not going to be A, but let's test out C, just to see if it would make more sense. Wow, would you look at that, they also made the line purple, which just matches with my line pretty much perfectly, so since they're both purple lines, and I guess they're both steep, C is gonna be our answer. So line number 22, once again we get a scatter plot and they want us to give an equation for the line of best fit. If we were to draw that real quick, it would look something like this. Just like our last question, instead of trying to actually find the equation, let's look at our answer choices and see which equation would make the most sense. First up, you'll notice that the answers are in y equals b plus mx form, so they kind of just moved the b to the front. We know that the line is going down, so it should have a negative slope, so instead of a plus, it should be a minus. So that gets rid of A and C. And then our B or our y-intercept or our starting point, it should be somewhere up at 10. So it's obviously not going to be 0.9. That means our answer is D. Would you look at that? Just by using our equations and our knowledge of the slope-intercept form, we instantly found the answer without doing regression or even plugging any of our answer choices in. But of course for fun, I will always do it. I just plugged in the equation. Now let's change the bounds. 0 to 10. 0 to 10. Oops. Oh, I don't even know what I'm doing anymore. Hold on. Alright, there we go. The two lines look pretty darn good. If we were to choose B, this is what it would look like. And that's definitely... Hold on. That's way too flat. It doesn't even show up on the screen. Here's A and C. Like, man, what is even happening, dude? Like, the three lines don't even fully go across the screen. The only one that does is D. Now we're moving on into our next topic. Let's get started with slide number 24. So our new topic is probability. And the thing you want to know about probability is that before you even start reading anything, there are some important tricks that will help you out immensely. So let's go ahead and take a look at our notes. First up, this is the probability equation. It's gonna be the number of things you want divided by the total number of things. But the most important part are the words that indicate the total number of things. So these are just a few. Now let's go back to our question. I didn't write this on the notes, but another thing you should know is that you only need to pay attention to the very last sentence. This first sentence right here, it literally just describes what you already see in the table. We don't need to be reading any of that. Now let's start reading our last sentence. Of those, here's a keyword that indicates the total. Of those presidents who were at least 50 years old when they first took office. That's gonna be our total number. That's gonna be our bottom number. It's gonna be the number of presidents that were at least 50 years old, so greater than 50 years old. We know that this is the bottom, we know that it's the total because of this keyword right here, of those. Let's finish reading. What fraction were at least 60 years old? So that's going to be the top of our fraction. That's going to be the number of things we want. Number of presidents that were greater than 60 years old, or at least 60 years old. And that's the hardest part of a probability question done. Probability is literally just reading. And then the reading isn't even that bad as long as you pay attention to these keywords. Once you set up your fraction, all you have to do is fill in the numbers. Alright, first up, let's look at how many presidents there were that were greater than 60 years old. It's gonna be these two right here, and we're gonna have 7 plus 3, which is 10 on the top. Now on the bottom, it's gonna be the number of presidents greater than 50 years old, or at least 50 years old. So that's gonna be from here to here. That's 13 plus 11 plus 10, and that's gonna be 34. So our answer will be 10 over 34, which is B. Slide number 25, once again, only look at that last sentence because everything above it is just describing what we already see in the table. Now let's start reading. If, keyword guys, right here, if the person chosen works in the human resources department, so we know that's going to be a bottom number, the total. They're going to have to work in HR. Let's keep reading. What is the probability that the highest level of education the person completed is a master's degree? So that's going to be our top number. It's going to be what we want. And what we want is that their level of education is a master's degree. So master's degree. Alright, and whenever I have a table that looks like this, I like to just block it out. So we know that our total is that they're gonna work in HR. So nothing in accounting. So HR, that's gonna be 4 plus 2. So our bottom number will be 6 because 6 people work in HR. And then for our top number, we want the number of people that have a master's degree. So that's just gonna be 2. Our answer will be 2 over 6. Or if we simplify that, that would be 1 over 3, which means our answer will be B. Now we're moving on into our next topic. Let's get started with slide number 27. Once again, just like probability, you only need to pay attention to the very last sentence because the first few just describing what you already see in the table. So here they're asking us for the reason why sample A has a bigger margin of error than sample B. Let's quickly take a look at our notes. Here we go. Error can come from sample size. If you have a larger sample size, you have a smaller chance of error. And if you have a smaller sample size, you have a larger chance of error. So if we apply that to our question right here, the reason sample A has a greater margin of error is because it had a smaller sample size. So that means our answer will be D. Slide number 28. They tell us that the proportion of a population that has a characteristic is 0.49 and it has a margin of error of 0.04. Based on this estimated margin of error, what is the most appropriate conclusion? Let's go ahead and take a look back at our notes. Whenever you have a margin of error, your result plus and minus your margin of error will give you an interval of possible values. So let's go ahead and apply that to our question. We want to get our result, which is 0.49, and then plus or minus our margin of error, which is 0.04. If we did 0.49 minus 0.04, we would get 0.45. And then if we did 0.49 plus 0.04, we would get 0.53. So our most appropriate conclusion is that the proportion of the population can be between 0.45 and 0.53. So that means our answer will be A. Slide number 29. Our result is that the estimated mean is 4.5 miles and the margin of error is 0.5 miles. Then they want us to find the best conclusion. Once again, you want to take your result and add and subtract the margin of error from it to get the interval of possible values. Our result is 4.5 miles, then we want to add and subtract 0.5 miles from it. If we subtract 0.5, we would get 4, and then if we add 0.5, we would get 5. So that means our answer can be between 4 and 5 miles, so it's not going to be B or C. Now we have to choose between A or D, because they both say between 4 and 5. Now the key thing you want to notice here is that they say it's the mean. Our result is the mean value. If we look at answer choice D, they also say the word mean. Since these both talk about the mean value, our best answer would be D. Now we're moving on into our last topic, and let's get started with slide number 31. So here they tell us there's a sample of 40 4th grade students and they did a little survey. Then they're asking us for the largest population the results can be applied to. Let's take a quick look at the notes. Whenever you're trying to find the largest population the results can be generalized to, the answer will always be the sample. But here's the thing, you always want to ignore any numbers associated with the sample. So let's go ahead and apply that to our question here. Our sample is 40 4th grade students. But once again, ignore the number. It's just gonna be 4th grade students. And that's your answer. That's the largest population it can be applied to. Just 4th grade students. Now obviously, our answer shouldn't have a number, and it's not gonna be all students, it's gonna only be the 4th grade students. Now we have to choose between at the school and in the county. And there's also a pretty clear answer. I kind of forgot to read it, but if you keep reading the rest of the sample, it's 4th grade students from a certain school. So the answer would obviously have to be at the school. It's not going to be in the county. Our answer will be B. Slide number 32. Once again, they're asking for the largest population the results can be generalized to. We know the answer is just gonna be the sample, so that's gonna be history professors from the California State Universities. That will be our answer. It's not gonna be just professors, it has to be history professors. It's not gonna be all the history professors in the United States, it's only gonna be at the California State Universities. That's gonna be our answer, which is C. Then once again, it's not just professors. So our answer is C, all the history professors at the California State Universities. Alright, that concludes all the questions I have for Mu Alpha Theta's tutorials on Domain 3, Problem Solving and Data Analysis. If you would like to get more practice on harder questions, please check out my SAT doc. Of course, let me quickly show you how to use it. You'll want to click on Math, and then our third domain, Problem Solving and Data Analysis. And just like the questions and slides, it's broken up by all of the different topics. And of course, I also have the questions, the answer key, and a video going through all of the questions. That's gonna be it. Good luck studying, and I'll see y'all. Min out.